discounts and markups. Okay, so remember we talked about wholesale price, retail price, and what all of that meant. And so we want to be able to apply the information from understanding those words into how we figure out how much money we owe. So retail, just to review, is the price at the store. But the store bought it from someone, and that's what we call the wholesale price. It's like the factory in China, okay? And it's where the store buys from. So the retail store buys the stuff, whatever the stuff is. Maybe it's a t-shirt or whatever, okay? And then we have to figure out a sale price or a retail price. So if we know, let's just do an example. If we know that the wholesale price is $30, and we know that the percent of markup is 70%, we want to solve for the retail price because we have the wholesale and we know that someone is buying it from the wholesaler, they are marking it up, and then they're going to sell it at their store. So we need to figure out what is the retail price. Okay, so to figure this out, we're going to take our wholesale price, the $30 that it costs to get it from the factory. Okay, the t-shirt costs $30 to make. So now Aeropostale is going to mark it up 70%. Well, if they mark it up, then we have to know what is 70% of 30. And what is 70% of 30 means multiply that 70% times 30. So let me write that question. What is 70% of $30? So if you convert this, like we've been talking about, into algebra, you can see the multiplication piece happening. And so now I'm going to multiply it, and I get 21, and I need 2 decimal spaces. So I have $21. Well, $21 is how much they marked it up. That's the 7%, it's 70%. So you actually have to add this dollar, or these 21 increase to the wholesale price because that's what the retailer is selling it for. So you have to take this markup amount, this 70% of $30, and you want to add it to the wholesale price, which was $30. And you get $51. And so this $51 is what the retail store like Aeropostale is then going to spend or sell the shirt for. Okay, let's do another one. So if you go to the store and the price at the store is $72. Whoops. But you have an 18% off coupon. And so a coupon is going to give you a discount. Okay? So we want to figure out, what do you actually pay at the store? So you're going to take your $72 that's on the price tag of the shirt, and you're going to multiply it by that 18%. And if you do the multiplication, I'm using my calculator, you get $12.96. Okay, well, this is the amount that's discounted. It's not what you pay. It's the amount that's discounted. So that's what you figured out is how much is off of the shirt. So now you have to take the price of the shirt and subtract the discounted price from it. And so you need to remember to add your zeros and borrow. Okay, 10 minus 6 is 4. 9 minus 9 is 0. 11 minus 2 is 9. 6 minus 1 is 5. And so the price that you pay after your coupon is $59.04. Okay? Now the last thing that I want to talk to you about is I want to talk to you about compound interest. Okay? So we've looked at simple interest, which has that easy formula. But we also have compound interest, which is not quite as easy to deal with. And compound interest has a different formula. It has that A, and if we remember, the A stands for the account balance. It's the amount in the account after you add the interest to it. Okay? And that A is equal to P times the quantity 1 plus R to the power of T. So we're using the same pieces of information. We're using a rate, we're using time, and we're using principal to get an account balance. However, you have to solve it a little bit differently. You have to use this formula when you're doing compound interest. And your problem will say, what is the compound interest after 10 years? Or what is the simple interest after so many years? Okay? So let's do a problem. Our compound interest we're given that P is equal to 800,000. So we're talking about maybe buying a house. The house costs $800,000. Your rate is 3%, and you're going to pay this off after 3 years. Okay, you want to pay the bank back after 3 years. So we're going to figure out what your compounded interest, how much you're actually going to owe. Okay? Excuse me. So I'm going to start with my formula. Always rewrite your formula, okay, to show that you can plug in the pieces that you need. So we're solving for our account balance, how much we're actually going to pay. Our principal rate is that 800,000. We have 1 plus R, and R is 0.03 because percent changed to a decimal is 0.03. And our time is 3 years. And now I'm going to solve. And according to GEMDAS, I have to do what's in my parentheses first, then my exponents, then my multiplication. So I'm going to leave my 800,000 alone for a minute. And I'm going to say that 1 plus 0.03 is 1.03. And it's to the power of 3. So I have to solve my exponent before I can do the next step. So I'm going to take my calculator out. And I'm going to do 1.03 times 1.03 times 1.03. And I get 1.092727. And I don't want to round or shorten my number because I want it to be as accurate as possible. And now I'm going to multiply that by the 800,000. And I end up with 874,181.60. And this is the dollar amount that my house is going to cost me because I had to pay a compounded interest. Okay? All right, you're going to finish up the worksheets that I left for you. They cover these concepts. I want you to make sure that you always use and write the correct formulas when you're solving your problem.